At the end of the last video, we have the sentence transformers loading this model, and we set the device to CPU. Because I'm on a M1 Mac now, I'm going to set the device to Metal Performance Shaders, or MPS. If we run our program, uv run python main.py, prints out that the platform is Mac OS. The MPS is available as true, and it successfully loaded the transformer model. We are building our index here on the left-hand side. We're using sentence transformers, and we still need to build the embeddings. I have my sentences here, and I have my 10 queries. That's in a list of strings here. I'm going to import NumPy. And by convention, we'll call it NP. Above this line, we have loaded the sentence transformer model. So we're able to use this word model here. We need to take these sentences and convert them into a set of numbers. We're going to call the set of number vectors of type NP array, ND array. The model is that we just defined it up here. And we're using the keyword encode. And we're going to encode all the sentences, which is the list of strings that we just have right there. We'll just make sure that it's actually loaded or converted. So there's a property in the vectors for D type or data type. Also check the shape. But there's another property here for shape. And the structure will be sentences plus the dimensions. We'll run it again. It may take a while, but it's encoding all the sentences right now. Loaded the sentences, encoded the sentences into vectors. We have the vectors as a float 32, which is what we need to get it into FAISS. The vector shape is there's 10 sentences and 384 dimensions. We now have the sentences in a set of numbers and vectors, but we can't do anything with it because we can't compare it right now. For that, we need FAISS. So step 3 is use FAISS to set up an index that we can use for comparison. We're going to compare it against a query. You need to import FAISS. I'm going to put a comment here. I know that it doesn't have the proper types in this version of FAISS. So my type checker is going to throw an error when it checks the type of the what the FAISS is exposing. We're going to use the built-in keyword index flat, so it's a little faster. L2 for Euclidean distance, and it will be 384 dimensions. IndexFlatL2 is simple and uses L2 Euclidean distance. Right now there's nothing in the index, but let's test it anyway. Okay, it's running with no errors. Let's add the vectors into the index. So it's index.add, keyword add, and then vectors that we created up there for the encoding. You can see the number of vectors that it added. Hopefully it added 10. We'll try it again. Okay, we've got 10 vectors in the database, which is our base data that we're going to query against. So you can save the index to disk, and let's do it right now. We're not going to read it from disk in this tutorial, but it will show you that you can save the index file itself to disk, so you don't have to re-index it every time. You don't have to re-encode it. We'll just call our file FAISS underscore index.bin. Then we'll just use FAISS write index, just built into FAISS. So it's going to write the index to the index file. Hopefully it was successful. And we'll just print out a log that it was saved to the index files. And my 10 queries here, the queries don't use the same keywords that's in the sentence data. So we're trying to make it so that's not going to show a keyword search here. That it is going to look for a similarity search. And then we'll import random so that we can grab a random query. The query will be a string because we just have a list of strings in Python. We'll use the built-in package or standard package random for choice. And what we call our list is a set of test queries. Maybe I should just call it queries. And we need to encode the queries. We're just using one query at a time. So step 7 will be to encode the single query. I'm emphasizing single because you can send multiple queries to FAISS. Okay, let's run it and see where we are. Okay, we're almost at the end of our journey here. So we have our set of texts, the sentences. We use the sentence transformers to encode it, and it has been embedded into a multi-dimensional array of 10 with 384 dimensions. These are all in float 32 using NumPy, make it into a NumPy array. And we've created our FAISS index of using this built-in IndexFlatL2 Euclidean distance of 384 dimensions, because that's how the embedding is. We also have our user query now, which is a string. We just use the sentence transformers to put it into the query embedding. And it's a NumPy array. We now need to just search on the FAISS index and compare the query against what we have embedded into it. Right now, our query is a string, right? Because it was a list of strings. We'll just do the query vector, which is a variable that we're deciding on, and the type will be npnd array, which is what has been fed into FAISS. we use our model that we loaded earlier. Query, it's a list here because it could be multiple queries. And we'll just tell it as type, which is float32. We're going to search for the two most similar sentences. It can be, there's no one right response, unlike, for example, a keyword search or something like that, where you just want one response. There's multiple responses, and we can just show one if you want to, but there's no one correct answer. It's just how similar they are. So we use index.search. We have our query vector, and we'll get k is how many we want to show that's similar. All right, let's test it again. We're not printing out the responses yet, but we just want to see whether it is encountering a problem. Okay, we have the single query here. It looks like it did do the search, but we need to now print it out. We're going to use a zero index, which is the number, it's the index of the query. We only have one query. So in our case, it's always going to be index 0 of the query. First, going to see what the distances are. So this thing that's returned is it's a list. And let's print out the indexes as well too. Which is going to return the index of the original data that has been indexed inside of the FAISS. So we're going to get a number, an integer. The distances here, it's how close they are. So the lower the number, the closer it is. This is the distance between the two vectors. This is for the one that's most similar, and this is the one that's not so similar, or second most similar. So it's the eighth in the index. The query is how do I build a mental strings to keep trying? It would be this one, resilience, because it's the eighth index. So it would be ninth, uh, the ninth line. Resilience is the quiet decision to try again tomorrow. Step 9 is to display the search results. But because we're dealing with a set of arrays, it's going to be a bit more involved. First, we need to get the index of the closest match. It's going to be an integer, and its indices 0, because it's the first query. There's only one query, and the closest match. So there's two indices, right? The first number, we're looking for an 8. So this is going to be 8. This list here, this is index 0, right? So this will be number 8. Index 0 is the number 8. We have our list of sentences, the list of strings. So theoretically, it should print out, well, we have it on random, so the query is going to change. The query is, how do I keep going when progress feels slow? The closest match is, progress is built one small consistent step at a time, which should be the first line. Just check it. Yep. It's the first line in our list here. It appears to be working. But we probably want to see the distance because we are doing this for educational purposes. We can compare the distance of the query versus what else we have going. Just put a separator here. In Python, if you do a multiplication like that, it'll print out 20 of these minus signs, just as a separator. Then we'll get the second match index. So the first 0 is for the query. There's only one query, so it's the first query. And index 1 is the second element in the list. So we'll just copy these two lines, put it down, and it's the second match. Instead of the closest match, we'll have second match index, and the distance index will be 1. Let's try it again. Right, so the single query is, how do I build mental strength to keep trying. And the closest match is resilience is the quiet decision to try again tomorrow with a distance of 1.21. Mental strength to keep trying. And the second match is the courage to start matters more than the confidence to finish. So this sentence is more similar to the query than this sentence. The distance is further. Right, congratulations. You now know how to use a vector index for similarity search. You can build the index, right? So you just have a set of sentences, and then you encode these sentences into a set of numbers using this Python package called sentence transformers. And inside of the sentence transformers, you have a package called NumPy, and that will hold this type of multi-dimensional array. In fact, we're using a 384 dimension array, which can be fed into the FAISS index. So it converts it to float 32, which is what FAISS requires, into a NumPy array. And then we apply a certain type of index to it, which is this IndexFlatL2 Euclidean search 384. So it's a simple one to calculate the distance between two different vectors. Once we have this on the left-hand side, the right becomes quite easy. We just use the same technique. We start with a string with a query, the question. We use the same thing, sentence transformers, to convert it into the embedding. It's the same embedding. There's only one of them, and there's 384 dimensions to it. In the case of the left-hand side, we embedded 10, but this time we're embedding 1. It converts it to the NumPy array, same as this. It's the same. Then we apply it to the FAISS search using the built-in index.search. We then get the results, and we use some simple going into the list to retrieve the matches. Once we have this basic structure, there's a lot we can do with it. This is very flexible. We could embed an index 1,000 lines of a spreadsheet, for example. And the spreadsheet might have data on who attended a certain technical conference. We could use it that way. We can store the text in a SQL database and set up a identifier to match up the result with the number in the index. And this is commonly used with RAG, the LLM. So in this case, you have a query. The query, same as our simple application here, is converted into an embedding. The question then, or query, is used to search in a vector database, same as we're doing right now. Then once we have the context of the question plus the relevant data from the database, then we pass it over to the LLM. And then we get the final answer from the LLM in a nice human understandable format. So drop a comment if you are interested in a particular use of the FAISS or similarity search, and we can then extend upon this type of project in the future. We'll be building out the application in this 100% free course, Industry Projects with Python. You'll have the code, a bunch of slides there, and more great information. Join us at industry-python.thinkific.com.